All right, today we're going to be talking about different types of solutions to equations. So we're going to start off with one solution, which you guys have seen, and then we're going to talk about no solution or infinite solutions. Before we get started, I need for you to go to Schoology, make sure you have downloaded this worksheet and you have printed it off and you can write on it. Or if you don't have a printer, then just create this chart in your notes and then you can just write in everything. So before you move on, please make sure you've done one of those two things so that you can write on or in the table and follow along with your notes. Okay, so today we're going to talk solutions. So we're going to start with one solution, which we have worked with. You guys have seen one solution equations for a very long time. So this is just a quick review, quick recap. So if I have 3x minus 1 equals 2x plus 9. Okay, so what I would like for you to do is to pause this video and I would like for you to solve this equation really quickly. All right, hopefully you paused and you're finished. So what I would like for you to do now is I want you to check your work with my work and make sure that you're getting the same solution. So get the x's together on one side and then add 3 to both sides, and we get x equals 12. So that's a typical one solution equation. Our final answer, what we get down to at the very bottom is we end up with a variable equals a number. Okay, could be any variable, could be any number, but you have a variable equals a number. So variable equals a number. There we go. Okay, variable equals a number. All right, so now let's talk no solution. All right, so now no solution. What does that look like? How do we know if it's a no solution equation? All right, so let's look at this equation. We have 6 parentheses x plus 5 equals 3, 1 plus 2x. All right, so same as always, we're going to start off the equation, by doing distributive property. So 6x plus 30 equals 3 plus 6x. All right, so now I'm going to get the x's together. So subtract 6x from both sides. So cancel over here. I'm left with 3 equals, and oh wait, I have 6x minus 6x. This is going to cancel as well. So now I'm just left with 30 equals 3. Does 30 equal 3 though? No, it does not. So look what happens. We actually eliminated the variable and we are left with two numbers that create a false statement. This is not true. 30 does not equal 3, right? So we would write no solution here. Okay, and then so to know whether or not you have an equation with no solution, your last line, or what you will get down to, is a false statement where the two sides of the equal sign do not equal each other. So what that's telling us is no matter what number I put in for x, fraction, a decimal, a whole number, no matter what, it will never, ever, ever, the two sides will never, ever equal each other. It's just not possible. This equation is just not possible. Okay, so with a no solution equation, you will get down to some sort of number equals some sort of other number, and it creates a false statement. Okay, that's a false statement. All right, and then lastly, we have infinite solutions. So you may already have an idea of what this is going to look like. So infinite solutions, let's test you out. Let's see if what you think is right. So let's look at the equation 2x minus x plus 7 equals 3 plus x plus 4. Okay, so before I start, there is no distributive property, so before I start moving things across the equal sign, I need to make sure the left-hand side and the right-hand side both are as simplified as they possibly can be. So I want to combine any type of like terms that I can. And I notice on the left side here that I have a 2x and a negative x. So I'm just going to go ahead and combine those two, and that just leaves me with x. Okay, notice I did not use opposite operations because they're on the same side. What I'm putting together is on the same side of the equal sign. So then I'm left with plus 7. And then over here on the right-hand side, I notice I have a 3 and I have a positive 4. So I'm just going to add those together, and that gives me 7, and then plus x. All right, so now if I need to get the x's on the same side, subtract x from both sides. Ah, look what happens. We actually eliminated the variable again. But this time, look what we have. We have the two sides that actually equal each other. So 7 does equal 7. So notice here, we end up with a true statement. So if it's infinite solutions, that means the two sides equal each other after we've eliminated our variable. Okay, so we would write this as infinite solutions. Okay, so for infinite solutions, you would get down to some number equals some number. So you would end up with a true statement. Okay, if it's no solution, it's false statement. If it's an infinite solutions, it's true statement. Now, you may have noticed right here at this line that the two sides were exactly the same. When you notice that the two sides are the exact same, then it's a true statement, then you know it's an infinite solution. So basically, by saying infinite solution, what that means is that it doesn't matter what number I plug in for x, the two sides will always equal each other. I could put 5 in for x and it would still work. I could put 25 in for x and it would still work. Negative 3.5 in for x and it would still work. Okay, so infinite solutions means that it doesn't matter what number you plug in, it will always, always work. Okay, so really quickly to recap, one solution, you get a variable equals a number. Okay, x equals 12, a equals 5.3, whatever. No solution, you end up with a false statement. You've eliminated your two variables, and what's left are two numbers that do not equal each other. So therefore, a false statement. And then infinite solutions is when you eliminate the two variables, and what you're left with are two numbers that do equal each other. So the two sides of the equal sign are the exact same. Okay? All right, if you have any more questions, please talk to Mrs. Caroline. Thanks.